Usually, sine and cosine are going to be reserved for either working with right-angled triangles or for identity-based equations, where you have to solve for expressions that contain sine and cos and tan and so forth later on in the course. The sine rule, the cosine rule, and that for the area of a triangle, therefore, are something of a bridge in between. We're going to be looking at angles and sides of triangles, but they're not right-angled triangles. And how we're going to work this through involves slightly more of an equation-based framing. If we were to say that we had any triangle like this, it can be right-angled if we want, but most of the time it won't be for these, where you have sides A, B, and C, and then the opposite angles are labelled the same letter, just usually capital versus lower. With this, therefore, we can say that for any triangle, the side A divided by the sine of the angle A gives you the same value as side B over the sine of angle B, and that gives you the same as side C over the sine of angle C. You may see this inverted, you may see it sine of the angle over side. It doesn't really matter so long as you're consistent as to which way up the fractions are going. In general, what I'd suggest is whatever you're looking for, whether you're looking for a side or you're looking for an angle, I'd put that on top. We'll go through an example of how to apply this formula in a second, but just to go through the rest first. The cosine rule is then that, again, starting with a side A, but now we're going to square it. This will be the same as saying b squared plus c squared, so these are the two sides squared, minus 2bc cos A. It is the longest of these formulas, but what it does is it uses two known sides and an angle to get the third side, or again, you can rearrange this however you wish to get one of the other sides or to get the angle and so forth. The main thing here is that this A on the left-hand side is the side that's opposite the angle A. They have to be opposite each other. B and C can then be the other sides in whatever order we wish. As for the area of any triangle, we can say that this will be the half times AB sine C. Well, again, AB have to be two sides that meet, and then C is the angle between them. In diagrams, you'll often have corners labelled anyway as A, B, and C, or sides instead. These do not have to relate to the A, B, and C in these formulas, nor if you start using one formula, say you pick a side being A here, when you go to A in the cosine rule, say if you're moving on to that doesn't have to be the same A. These letters are just standing in for any sides with these relationships relative to whatever angle. So, for some examples, let's say we have this triangle here, where we know this angle on the bottom right is 25 degrees, this angle on the bottom left is 130, this side on the top right is 4, and then on the left here we have an x that we're trying to find. Well, here we have two angles and two sides involved. When I say they're involved, it doesn't mean we have to know all of them. One of them will be an unknown, but the question contains them. So for two sides and two angles, we're going to be looking at the sine rule. We're going to be looking at how this side is opposite this angle, and this side is opposite this angle. Therefore, we can say that 4 over sine of 130 is the same as x over sine of 25. Rearranging this, you would get that x equals 4 over sine of 130 times sine of 25. And putting this into your calculator in degrees, let's say we go to 3 significant figures or 2 decimal places, that will get you 2.21 centimeters in this case. As for this other triangle, which we can use for the cosine or the area, let's say that we have all 3 sides right now, and we're trying to find an angle. The equation or the question involves all 3 sides, maybe the cosine rule, because it has all of A, B, and C involved. If we're trying to find this angle here, that's going to be our capital A. That makes the 7 our lowercase a. then the other two sides can be B and C in whichever order. Let's just label the 8 to the B and the 6 to C. We're trying to find the angle, which right now is not the subject in the formula as it's been given, but let's plug in what values we know in that order right now, and then we'll rearrange. So for our A, you've got your 7, so 7 squared equals 8 squared plus 6 squared minus 2 times 8 times 6 times cos of x. Now to rearrange to get the x on its own, what we may do first of all is minus these two values across. So you get 7 squared minus 8 squared minus 6 squared. Now this otherwise would equal minus 2 times 8 times 6 cos x. But again, because we're trying to get the x on its own, we'll then divide by the minus 2 times 8 times 6. So that gives us our cos x. Now this you could either put into your calculator right now or leave as a fraction for the second. It's up to you. Either way, the x therefore is going to end up being the cos inverse of this to get the cos out of the x as well. And if you put that whole thing in the calculator, whether it's the answer from before or all this in one go, let's say again 2 decimal places, you would get an angle of 57.91 degrees. As for the area, now that we know the angle of this triangle, we can now label this angle C. Then these two sides can be A and B. So the area will equal half times 8 times 6 times sine of the 57.91. If you can keep this in your calculator as the complete decimal, that will just make your answer even more accurate. But either way, right now we say round 2 decimal places, you would get an area of approximately 20.33 square miles. So this is how we can use these rules individually. What if we had one question that contained all three of them? We have here a four-sided shape, ABCD. We know that the length AD is 11 meters. We know that the angle ADC is 105 degrees. Angle ACB is 48 degrees. And angle ABC is 118 degrees. The area of ACD, so the bottom triangle, is 56 meters squared. Find the length of AB. Well, if we're trying to find the length of AB, we're going to be looking at this triangle on the top. So this would be a side that's opposite an angle, great. But if we were to use this angle as well, therefore, well, we don't know what side AC is. However, we're not going to give up hope because AC is a side on the bottom triangle. So if we can use the lower triangle to get AC, we can then use the sine rule on the top triangle. I'm just going to label AB like X, just so we have it, because that is our final answer that we're trying to get. In order to get this side, though, right now we're still lacking information. We only have one side and one angle. We can't use the cosine rule, we can't use the sine rule, but we are told the area. We know that, okay, so it would be half times 11 times CD, that times sine of 105, that would equal the 56. So, just rearranging, you get CD as being 56 over a half times 11 times sine 105, and 2 decimal places, this would get us a length of 10.54 meters. Now that we have this, we have two sides and an angle between them, and we're after a third side. This will be the cosine rule, therefore, because it involves all three sides. And we now know the angle that's opposite that side. Let's say that's just saying your B and that's your C. So your AC squared is going to equal 11 squared plus 10.54 squared minus 2 times 11 times 10.54 times cos 105, and just putting that all in to start off with will get you to 2 decimal places, 292.13. So then AC on its own is going to be the square root of that. We'll just go to this, which again 2 decimal places, 17.4 17.09 meters. Now that we have AC, now you can use the sine rule on the top triangle. So this 17.09 over sine 118 is going to be the same as x over sine 48. So x is going to equal 17.09 over sine 118 times sine 48, which gives us an approximate value of 14.39 meters for AB, our answer. If we're happy with how we have been able to implement all three rules there, based on what piece of information we had at any given time in the question, let's just see how you could get on with a question of your own. Let's say we had another triangle here, which we will label A, B, and C. Down in this corner, it's going to be 45 degrees. This side is only going to have an expression x plus 3. And this side here is only going to be called 2x minus 1. Now we know the area of ABC equals 6 root 2. Find x. Obviously, this is slightly different to what we've had before because now we have multiple examples of this unknown x. But all the same, consider what information you have, which rules that might fit into, and how you can therefore apply these concepts to find your answer. Pause the video, have a go for yourself, and then press play again when you're ready to compare. Alright, so because we know this is to do with the area, we'll start off by setting up that equation. So we will have a half of 2x minus 1 times x plus 3 times the sine of 45. That would equal the 6 root 2. Therefore, just leaving these brackets here, you have 2x minus 1, x plus 3, but that will then equal the 6 root 2 over the half sine 45, which, if you put that in your calculator, actually comes out to just 24. Expanding these brackets then, you get 2x times x is 2x squared, 2x times 3 is 6x, minus 1 times x is minus x, so 6x minus x is plus 5x, and then minus 1 times 3 is minus 3. This equals 24, therefore 2x squared plus 5x minus 27, because you're going to minus 24 over to get a 0 on this side, will equal 0. Now that everything's on this side, we have a quadratic that we can solve. This does not go into two brackets, so we're going to want to use the quadratic formula. If you wish for more of an introduction into the quadratic formula or more examples on how to use it, I would look to the expanding and factorising video. But here we'll just say that because the formula is minus b plus or minus square root b squared minus 4ac over 2a, and in this case your b is 5, so minus 5 plus or minus the square root 5 squared minus 4 times your a is 2 times your c is minus 27 over the 2 times 2. Doing this once with a plus and once with a minus gets you possible values, again to two decimal places as we have been. X is either 2.63 or minus 5.13. With this in mind though, only one of these answers can be true. And the reason is, this negative, well, you can't have a negative length. If we were to have minus 5.13 plus 3, that still leaves us with a negative. Can't be a negative distance, so we ignore the negative, even though that's what will work out mathematically. Practically, the only answer that we will accept is the positive, the 2.63. Okay. If we're happy with that, let's just look at a further question. So the diagram shows the hexagon ABCDEF, which we can see is this kind of like arrow head shape, and it's made up of congruent, meaning identical, parallelograms. So these vertical lines are parallel to each other, BC is parallel to ED, AB is parallel to EF, and everything I just said was parallel is also the same length as the other thing I said it was parallel to. So we're told that AB and BC are each x, so we can label that on now if we want. Point P is on the point AF, and Q is a point on CD, such that B to P equals B to Q, and in each case those are 10. So again, I'm just going to draw those on. I'll end up redrawing the relevant parts of this in the space to the side in a second, just so it's clear, so there's not conflicting lines overlapping with each other, but just to label for now, this is what we have. Now, given that the angle ABC, so the whole angle here is 30, prove that the cosine of PBQ, so this smaller angle in here, is equal to 1 minus 2 minus the square root of 3 over 200 times by x squared. Clearly there's just a little bit of a formatting hiccup here, but that's what we're trying to show. So, what could we possibly do to try to get to this point? Well, because we're after this angle here, and because of the topic of the paper, we're going to be thinking about triangles. We're going to join up P and Q as a triangle like so. So you have this PBQ. We know two of these sides here, and we're trying to find this angle. If we can find out this side here, this length PQ, we can therefore use the cosine rule, which, oh no, that seems like it's on the right line, because we have this cos in our answer. To get PQ though, we're going to have to work with some other details first. As I said, I will just redraw out some sections. So what I'll do to start off with is I'll redraw ABC, and what I'll actually do, just as I have with the PQ, I'm going to join these up in a triangle. So we now know that this is 30 degrees, that this is x, and this is x. Well, if we're trying to find this length here, what we can do is we can indeed implement the cosine rule. Yet again, we're going to be doing it twice in this question. So we'll say that this unknown AC, that's going to equal x squared plus x squared minus 2 times x times cos 30. I've tried to differentiate here between multiplication x's and algebraic x's. Hopefully that's fine. In front here, that's just going to be 2x squared, and this will then be minus 2x squared times by, and if you put in your calculator cos 30, if you're not familiar with that value already, because it is technically among the values you may be expected to know, that is root 3 over 2. Now, times by 2, divide by 2, they're going to cancel, leaving you with just 2x squared minus root 3 x squared, which if you wanted, you could factorize to make it a 2 minus root 3 lots of x squared. This is your AC squared. AC then on its own would be the square root of this. Now, because these are two parallelograms, and so AF is going to end up parallel to CD, this means the distance between the far left and the far right is constant as you go down. Therefore, PQ is going to equal AC. So, when we get into doing the cosine rule for this inner triangle, we can say then that when we have our PQ squared equals, so it's going to be 10 squared plus 10 squared minus 2 times 10 times 10 times cos of, let's just label this angle theta, because we've already got x's. This PQ squared will be the same as AC squared. You know, AC squared was this. So you've got your 2 minus root 3 x squared equals 10 squared is 100, so 100 plus 100 is 200. This here, 2 times 10 times 10 is also going to be 200, so minus 200 cos theta. We're going to be trying to get this cos theta on its own. Right now that term is negative though, so we could add it onto the left and then minus this back over. So 200 cos theta equals 200 minus 2 minus root 3 x squared. And to get the cos theta on its own, this being the cos PBQ we're trying to find, if you divide by 200, 200 divided by 200 is just 1. And then this ends up being 2 minus root 3 over 200 x squared, just as we had to show.